Hello again, Year 9. Welcome to second week of Crude Oil and Fuels. Your starter this week is a 5, 4, 3, 2, 1. So first question has got 5 answers, second has got 4. It covers quite a lot of revision, just making sure that we're staying on it. All the answers will be in your knowledge organiser, but hopefully you shouldn't need to look them up. Remember, you can pause the video while you answer this. Right, in red are all your answers. If you weren't sure about any of these, then that gives you a little bit of extra revision to do this week. It's not that you've got anything else to do now that sports week is finished, is it? Let's be fair, it's sports month. Right, here are your objectives. You've got 3 things to learn this week. You need to know what fractional distillation is. You need to be able to explain how it works. That means you need to be able to understand it. You need to be able to teach it to someone. So you might want to use a parent or a sibling as a way of testing that. And you will need to know the names of the 6 fractions that are produced from crude oil when fractional distillation takes place. So first thing, crude oil as it comes out of the ground looks rather like this gloopy black stuff on the left hand side here. It is a mixture of lots of liquids. You can see that it's pretty homogeneous. It looks just like black goopy tarry mix. You can't clearly see there are different sections, but you do actually have a number of products. You have gasoline, which we call petrol. In this country that includes petrol and diesel, liquid petroleum gases, LPG, sometimes also used as a fuel for vehicles, heavy fuel oil, that's the sort of oil that's used by things like tankers, which you can see, and cruise ships that have great big chimneys on the top. Other products, jet fuel, heating oil, diesel. So lots of different things that are quite important to us here, and they all come from crude oil, which actually means you've got quite a problem, because obviously crude oil is, as we already know, a finite resource. It was made millions of years ago. We're using it up quickly. We haven't got millions of years to wait for it to be produced, and we don't necessarily have the right types of plants and animals dying to produce it anyway. So we need to make sure we can separate the parts and use this and make as much as efficient as possible. Now, what we already know that can help us, ways to separate. A mixture is a number of elements or substances that are in the same space, but they are not chemically bonded to each other. This is all revision here. You should already know this. If you don't, make sure you make notes of things that aren't familiar. Things in a mixture can be separated using differences in their properties. Solids of different sizes can be separated using a sieve. You will have done that if you've had rocks and sand, for example. I've done it in my garden recently, sieving big stones out of some earth I had delivered, so I didn't have big stones everywhere. Dissolved solids can be separated from a liquid by using crystallization. But if you have a mixture of solid liquids and they've got different boiling points, they can be separated by the process of distillation. Another little bit of revision, you've probably already seen this. This piece of equipment is called a Liebig condenser. You have a round bottom flask over here on the left, to which you apply a heat source. When we are separating water and ethanol, you've probably seen this done at school, we tend to use a container that heats it rather than using a Bunsen burner, because ethanol is actually highly flammable. You have a thermometer here so you can check the temperature that the gases being produced in the neck of the flask are at. Then the condenser here has 2 parts. It has a tube going through the centre which takes the gases, and then around the outside it has a second layer which has cold water coming in at the bottom and out at the top. And this cold water reduces the temperature of the boiling gases so that they condense again back to a liquid, hence the fact it's a condenser. And here we will take out, this is using salt water, you've got pure water coming out and salt being left behind. We've used it for water and ethanol at school. Ethanol boils at 79 degrees centigrade, whereas water boils at 100, so we would actually have ethanol at the bottom and water left behind. Slightly more complicated when it comes to crude oil, because there are actually 6 different liquids. So I have put in a video link here so you can watch a video, see this in action, and you don't have to listen just to me. But you have got 5 questions below it. Now you need to write those questions in your book before you watch the video, because you're looking for the answers and you don't want to have to try and remember the questions as well as find the answers. Leave yourself a couple of lines underneath each question so you've got space to write the answers. It's a little bit like a structure strip, and as the questions are in sentences, so should your answers be. So you need to know what fractional distillation is, what property of crude oil is used to separate the fractions, what is the name of the piece of equipment used, which fractions come off lower down, and what the 6 fractions are all together. The link for this video will also be posted in Teams and Go for Schools, so you don't have to freeze the video and watch it here unless you want to. Now this is a classic diagram of a fractionating column. So you've got your crude oil mixture at the bottom, you've got little bits going off all over the place, and you've got a set of labels, which as you can see have got dotted lines. So you've got labels that name the fractions, you've got the name of the column, you've got a couple of arrows. This, you can either copy this and put the labels in the correct place, or there is also a printable version which will be on, the links for that will be on Go for Schools and Teams. If you could submit your finished diagram to show me you've understood it, that will be absolutely great. This is a standard sort of question you get asked in an exam, so you really need to understand how it works. If you're not sure where the labels go, I'm going to suggest you go back and re-watch the video so that you really understand it. It's just one property being used to separate out all 6 of the fractions. It's very clever, sounds very simple. When you look at this piece of equipment here, it's not quite as simple as it seems. And finally, it's a quiz. You know that. You're getting really good at doing these and submitting these to me. We've had a number of 10 out of 10s, so as it's nearly the end of term, I want to keep your enthusiasm up. I'm going to say to you, usual thing, R2 for another submission of your quiz result, and R3 if you get 10 out of 10. I know that a number of you have been doing this, and you can actually look at the pages before the quiz on BBC Bite Size just to make sure you're clear before you take it, to improve your chances. And we do know that we've got some really clever people in Year 9. We have 3 people that did really well on the Tassamai leaderboard this week, and doing this sort of thing will help you do really well next week. So you have got a video to watch, you have got a diagram to copy and label, and you have got a quiz to take. Now I know that's quite good but not enough, so I'll remind you that on Wednesday you will also have had a new Seneca assignment, and again there is an R2 available for submitting your Seneca assignment. So some people will have got themselves 2 R2s just by doing their work, just by submitting their Seneca assignment. Some people have got an R2 and an R3 because they've also got a quiz with a score of 10 out of 10. Don't know quite what the R points will work for yet, because I'm not sure that we're going to be doing trips in September, but hey, let's earn them and let's see where it takes us. As usual, I'm available on Teams and on email if you've got any questions, or for you to submit your work. Not in school this week, so I'm available all the time to answer your questions, well, apart from when I'm asleep, obviously. So have a good week, everybody. Any confusions, check in with me. Otherwise, next video next week. Take care, Year 9. Bye for now.